general relativity step by step. I'm going to give an example now of my peculiar h theta space, where we have h equals x and theta equals arc tan y over x, or I guess x equals h and y equals h tan theta. So I spent quite a long time figuring out what the coordinate, what the metric tensor looks like in these coordinates. And it's equal to this, sec squared theta, I'm going to run out of space, h sine theta sec cubed theta, h, oops, does that from time to time, h sine theta sec cubed theta, this is h squared sec to the 4 theta. What I want to do now is to find g in the same coordinates, ij, with superscripts there. And of course this is equal to the matrix inverse of this. I'll just write in what it is. That's the h and that's the theta, that's the h and the theta. So for example, if I want to identify this column here, I will say that g h theta equals h sine theta sec cubed theta, sec cubed theta. So I can identify by writing the actual components themselves as subscripts rather than just an I and a j, which are free. That equals the matrix inverse. So what's the matrix inverse? Well, a, b, c, d to the minus 1. It's not very neat. I'll start again. D to the minus 1 equals 1 over ad minus bc times switch and swap. Switch and swap the signs. Or is it swap and sign? I can't remember. Right, there it is. So I need to find out this guy here. So first of all, what's the determinant? Equals, well, it's ad minus bc equals h squared sec to the 6th theta minus this term squared. So it's h squared sine squared sec to the 6th theta. It's not as bad as it looks. H squared sec to the 6th theta, 1 minus sine squared theta. You see it's coming together. H squared sec to the 6th theta times cos squared theta, which is of course h squared sec to the 4th theta. Well, that's nice. Okay, so what's my matrix inverse? Well, I better write it down. I'll pinch in just a little tiny bit here. So G superscript ij is going to be the matrix inverse of this guy here, which is 1 over the determinant, h squared sec to the 4 theta times switch and swap. H squared sec to the, h squared sec to the 4 theta, sec to the 4 theta. Putting that up there, we swap these two guys around. So there is sec squared, and here we just change the sign. It's symmetric anyway, so yeah, it's non-diagonal but symmetric. So it's h minus h sine squared sec cubed minus h sine theta sec cubed, theta sec cubed theta minus h sine theta sec cubed theta. Multiplied by 1 over the determinant. So the determinant is that times 1 over h squared sec to the 4 theta. Oh, which I've got there, of course. Right, so let's have a look at that. That equals, oh, I've written the determinant here as well. Let me just get rid of that. Okay, so that equals 1. Is that right? Yeah, we've got an h squared sec to the 4 and h squared sec to the 4 minus 1 over h, and then we've got sine theta cos theta, I guess. Here's the same, minus 1 over h sine theta cos theta, and here we've got a sec squared over sec to the 4, so it's 1 over h squared. That's going to be cos squared theta over h squared. So there's my coefficients Gij. So for example, I might write that GHH equals 1, GH theta equals this term here. Actually, it's symmetric, G theta H. but they're both of them equal to minus 1 over h sine theta cos theta, and g theta theta equals this one here, cos squared theta over h squared. There we go. Perfectly sensible. I'm going to stop there. That's a nice one.